Sandwich theorem. If f of x less than or equal to g of x less than or equal to h of x, if f of x less than or equal to g of x less than or equal to h of x is defined in the deleted neighborhood of x when limit extends to a, f of x is equal to limit extends to a, g of x is equal to limit extends to a, h of x. Limit extends to a, h of x. Sandwich theorem means if f of x less than or equal to g of x less than or equal to h of x is defined on the deleted neighborhood of a when limit extends to a, f of x equal to limit extends to a, g of x equal to limit extends to a, h of x. And next one, suppose if limit extends to a, f of x is equal to L, then limit extends to a, f of x minus L equal to limit extends to f of x minus L equal to that is equal limit extends to a, f of x minus L. Here limit extends to f of x equal to L, that is L minus L equal to 0. L minus L equal to 0. If limit extends to a, f of x is equal to infinity, if limit extends to a, f of x is equal to infinity, then limit extends to a, 1 by f of x is equal to 1 by limit extends to a, f of x. 1 by limit extends to a, f of x, that is equal to 1 by infinity, that value is equal to 0. And next one, if limit extends to f of x is equal to minus infinity, if limit extends to minus infinity, f of x is equal to minus infinity, then limit extends to a, f of x equal to minus infinity, then limit extends to a, 1 by f of x is equal to, that is equal to 1 by limit extends to a, f of x. 1 by limit extends to a, f of x, that is equal to 1 by minus infinity, is also equal to, value is equal to 0. Suppose if limit extends to a, if limit extends to f of x is equal to 0, then limit extends to a, 1 by f of x is equal to, that is equal to 1 by limit extends to a, f of x, that is equal to 1 by 0, is equal to infinity. And next one, indeterminate forms. Indeterminate forms. 0 by 0, any limit of the function, any limit value of the functions are of the form 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 0 power 0 or 1 power infinity are said to be indeterminate forms, are said to be indeterminate forms. The forms are 0 by 0 or infinity by infinity, infinity minus infinity, 0 into infinity, 0 power 0, 1 power infinity and infinity power infinity. And the models are said to be indeterminate forms, are said to be indeterminate forms. If x belongs to 0 comma pi by 2, if x belongs to 0 comma pi by 2, then sin x less than pi by 2, then x less than tan x. If x belongs to 0 comma pi by 2, sin x less than tan x. If a limit extends to a, x power n minus a power n by x minus a is equal to, if a limit extends to x power n minus a power n by x minus a is equal to n into a power n minus 1 when x not equal to a, n into a power n minus 1 when x not equal to a. Similar limit extends to a, x power m minus a power m by x power n minus a power n is equal to m by n into a power m minus n. Here also same x not equal to a. Limit extends to 0, e power x minus 1 by x is equal to 1. E power x minus 1 by 1 x equal to 1. Limit extends to 0, a power x minus 1 by x is equal to log a to the base e. A power x minus 1 by x is equal to log a to the base e. Continue. And next one, limit extends to 0, sin x by x equal to 1, limit extends to 0, tan x by x equal to 1, limit extends to 0, sin inverse x by x equal to, limit extends to 0, tan inverse x by x equal to 1, sin inverse x by x equal to, limit extends to 0, tan inverse x by x equal to 1, and limit extends to 0, sin kx by x equal to, limit extends to 0, tan kx by x is equal to k, and limit extends to 0, sin ax by sin bx is equal to, limit extends to 0, tan ax by tan bx is equal to, limit extends to 0, sin ax by tan bx is equal to, limit extends to 0, tan ax by sin bx, tan ax by sin bx is equal to a by b. And next one, limit extends to 0, 1 minus cos kx by x square is equal to, 1 minus cos kx by x square is equal to k square by 2. That is the limit extends to 0, 1 minus a cos x by x square is equal to 1 by 2. 1 minus cos x by x square is equal to 1 by 2. And next one, go to infinite limits. Infinite limits. Let small a belongs to R, let small a belongs to R, and f be a function defined, and f be a function defined in the deleted neighborhood of capital A of small a, and f be a function defined on deleted neighborhood of capital A of a small a, then limit extends to a, then limit extends to a, f of x is said to be infinite limit of the function at a small a and is represented by limit extends to a, f of x is equal to infinity. Limit extends to a, f of x is equal to infinity. That is the limit extends to infinity. Suppose if ax plus b by cx plus d, suppose if ax plus b by cx plus d is equal to limit extends to infinity. In numerator and denominator x is common, that is x of a plus b into 1 by x by x of c plus d into 1 by x. Here x is cancelled. As x tends to infinity, that implies 1 by x tends to 0. That is the limit extends to infinity. A plus b into 1 by x by c plus d into 1 by x, that is equal to a plus b into 0 by c plus d into 0, that is equal to a by c. That is equal to a by c. And next one, limit extends to infinity. Limit extends to infinity. Ax square plus bx plus cy dx square plus ex plus f, dx square plus ex plus f. Take numerator and denominator, x square is common, that is the limit extends to infinity. X square of a plus bx by x square plus c by x square by, denominator x square is common, d plus ex by x square plus f by x square. Here x square cancel, 1x cancel, here also x cancel. As x tends to infinity, that implies 1 by x tends to 0. That is equal to a plus b of 0 plus c of 0 square by d plus e of 0 plus f of 0 whole square. That is equal to a by d. That is equal to a by d. And next one, limit extends to infinity. Ax plus b by cx square plus dx plus e. Cx square plus dx plus e. In numerator x is common and denominator x square is common. That is the limit extends to infinity. X of a plus b by x. And denominator x square is common, c plus dx by x square plus e by x square. Here 1x is cancelled. That is the limit extends to infinity. 1 by x of a plus b of 1 by x by c plus d of 1 by x plus e of 1 by x whole square. As x tends to infinity means 1 by x tends to 0 is equal to a plus b of 0 by c plus d of 0 plus e of 0. It is equal to 0 of a by c of 0. It is equal to 0. And next one, limit x tends to infinity, ax square plus bx plus c by dx plus c. Limit x tends to infinity, ax square plus bx plus c by dx plus c. In numerator x square is common and denominator x is common, that is a plus b by x plus c by x square. By denominator take x is common, that is x of d plus e by x. Here x cancel, x tends to infinity, that is the limit x tends to infinity, x into x of a plus b of 1 by x plus c of 1 by x whole square by d plus e of 1 by x. D plus e of 1 by x. As x tends to infinity, that implies 1 by x tends to 0. As x tends to infinity, 1 by x tends to 0. That is the infinity of a plus 0 by d plus 0. That is equal to infinity. And next one, go to results. Limit x tends to 0, 1 plus x whole power 1 by x is equal to e. Limit x tends to 0, 1 plus x whole power 1 by x is equal to e. And limit x tends to 0, 1 plus kx whole power 1 by x is equal to, limit x tends to 0, 1 plus x whole power k by x is equal to e power k. 1 plus x whole power k by x is equal to e power k. And next one, limit x tends to infinity, 1 plus 1 by x whole power x is equal to e. And next one, limit x tends to infinity, 1 plus k by x whole power x is equal to, limit x tends to infinity, 1 plus 1 by x whole power kx is equal to e power k. And next one, limit x tends to 0, log of 1 plus x by x is equal to 1. Limit x tends to 0, log of 1 plus x whole power 1 by x is whole power log of 1 plus x by x is equal to 1. And next to go to some examples. And first one, suppose if limit x tends to 2, x square minus 4 by x minus 2. Limit x tends to 2, x square minus 4 by x minus 2. First of all, substitute the limit, it is 4 minus 4 by 2 minus 2, it is 0 by 0. 0 by 0 means indeterminate form. Indeterminate form. The numerator is divided into factors, that is the limit x tends to 2. X square minus 4 factors are x plus 2 and x minus 2. In denominator, x minus 2. Here x minus 2 is cancelled, that is the limit x tends to 2, x plus 2. Put x is equal to, that is a 2 plus 2 equal to 4. And next one, limit x tends to 2, x cube minus 8 by x square minus 4. Limit x tends to 2, x cube minus 8 by x square minus 4. Substitute the limit is also in the form 0 by 0. Is also in the form 0 by 0. There is a 2 cube, 8 minus 8 by denominator, 4 minus 4. This is also in the form 0 by 0. Split into factors. There is a numerator, that is, you can written as x cube minus 2 cube by denominator x square minus 2 square. The numerator is of the form a cube minus b cube, denominator is of the form a square minus b square. That is the limit x tends to 2. A cube minus b cube factors are a minus b into a square plus ab plus b square by denominator a square minus b square factors a plus b of a minus b. That is x minus 2 of x plus 2. Here x minus 2 cancel. Substitute x equal to 2. That is a 4 plus 4 by denominator 2 plus 2. That is a 12 by 4 is equal to 3. Is equal to 3. And next one, limit extends to 0. Tan x minus sin x by x cube. Limit extends to 0. Tan x minus sin x by x cube. This is also form 0 by 0. Substitute the limit is of the form 0 by 0. Tan x can be written as in terms of sin cos, that is a sin x by cos x minus sin x by x cube. In numerator sin x is common. It is sin x of 1 by cos x minus 1 by x cube. And the second term is LCM, that is the limit extends to 0. Sin x by x into LCM is cos x, that is 1 minus cos x by x square into 1 by cos x. 1 minus cos x by x square into 1 minus cos x square into 1 by cos x. Separate the limits, that is the limit extends to 0. Sin x by x into limit extends here 1 minus cos x value is 2 sin square x by 2 by x square into limit extends to 0 1 by cos x. Limit extends to 0 1 by cos x. Here sin x by x value is 1. Here 2 is common. It can be written as the limit extends to 0. Sin of 1 by 2x by x whole square. Put x equals in the last term, that is a cos 0. The second one is of the form sin ax by x. Sin ax by x value is a. That is a 2 of 1 by 2 whole square into cos 0 value is 1. That is equal to 1 by 2. The value is equal to 1 by 2. And next example is limit extends to 0. 1 plus x whole power 1 by 3 minus of 1 minus x whole power 1 by 3 by x. 1 plus x whole power 1 by 3 minus of 1 minus x whole power 1 by 3 by x. The limit, after limit substitution, this is of the form 0 by 0. That is the limit extends to 0. 1 plus x whole power 1 by 3. Adding and subtracting 1. That is 1 plus x whole power 1 by 3 minus 1 plus 1 minus of 1 minus x whole power 1 by 3 by x. That is the limit extends to 0. Written as 1 plus x whole power 1 by 3 minus 1 by x minus of 1 minus x whole power 1 by 3 minus 1 by x. Limit is separated to two terms. That is the limit extends to 0. 1 plus x whole power 1 by 3 minus 1 by x minus limit extends to 0. 1 minus x whole power 1 by 3 minus 1 by x. 1 minus x whole power 1 by 3 minus 1 by x. As the limit extends to 0, 1 plus x tends to 1. That is 1 plus x whole power 1 by 3 minus 1 power 1 by 3 by denominator 1 plus x minus 1. Denominator can be converted into 1 plus x minus 1 plus limit 1 minus x tends to 1. It is 1 minus x whole power 1 by 3 minus 1 by 3 by 1 minus x minus 1. This is in the form x power n minus a power n by x minus a. Limit extends to a. Limit extends to a. X power n minus a power n by x minus a. The formula is limit extends to a. X power n minus a power n by x minus a is equal to n into a power n minus 1. N into a power n minus 1. That is equal to 1 by 3 into 1 power 1 by 3 minus 1 plus 1 by 3 into 1 power 1 by 3 minus 1. It is 1 by 3 plus 1 by 3. It is equal to 2 by 3. Limit extends to 0. 3 power x minus 1 by square root of 1 plus x minus 1. 3 power x minus 1 by square root of 1 plus x minus 1. Substitute the limit is in the form 0 by 0. You put x equal to 0. That is 3 power 0 value 1, 1 minus 1 0. In denominator 1 minus 1 0. 0 by 0 form. First of all, rationalize the denominator. It is a 3 power x minus 1 by square root of 1 plus x minus 1 into square root of 1 plus x plus 1 by square root of 1 plus x plus 1. In denominator, a minus b into a plus b form. In denominator, a minus b into a plus b form is a square minus b square. That is the limit extends to 0. 3 power x minus 1 into square root of 1 plus x plus 1 by square root of 1 plus x whole square minus 1 square. The denominator form is a square minus b square. This is equal, limit extends to 0. 3 power x minus 1 into square root of 1 plus x plus 1 by, here square root gets cancelled, there is a 1 plus x minus 1. In denominator, minus 1 plus 1 cancelled. That is a limit extends to 0. 3 power x minus 1 by x into limit extends to the square root of 1 plus x plus 1. The first term is of the form a power x minus 1 by x. A power x minus 1 by x is log a. It is a log 3 into, put x equal to 0. The square root of 1 plus 0 plus 1 is equal to 2 log 3. 2 log 3 basic. Infinity minus infinity model. For an example, limit extends to 1. 1 by x minus 1 minus 2 by x square minus 1. Limit extends to 1. 1 by x minus 1 minus 2 by x square minus 1. After substitution of limits, it is 1 by 0 minus 2 by 0. It is equal to infinity minus infinity form. For any infinity minus infinity form, LCM the denominator, that is x minus 1 into x plus 1. In numerator, x plus 1 minus 2. That is the limit extends to 1, x minus 1 by x minus 1 into x plus 1. Here x minus 1 cancel. Put x equal to 1 is equal to 1 by 1 plus 1 is equal to 1 by 2. And next one, verification of the limit. Verification of limit of a function. Suppose if the function f of x at x equal to a, if the function has a limit at x equal to a, the function has a limit exists when limit extends to a minus f of x equal to limit extends to a plus f of x. If the function has a limit exists when left limit is equal to right limit, that is limit extends to a minus f of x equal to limit extends to a plus x. Some examples. F of x is equal to, the function f of x is defined as x square plus 1 when x is greater than or equal to 1, 2x when x is less than 1, 2x when x is less than 1. Check the function has a limit exist or not. Suppose first one go to left limit, that is the limit extends to 1 minus f of x. 1 minus means less than 1. When x is less than 1, the function is defined as f of x equal to 2x. It is equal to 2 of 1 is equal to 2. The left limit value is equal to 2. And next one go to right limit. Suppose if limit extends to 1, 1 plus f of x equal to, 1 plus means greater than 1. That is the limit extends to 1. When x is greater than 1, function is defined as f of x equal to x square plus 1. Suppose the given function is defined when x less than 1, f of x equal to x, when x greater than or equal to 1, f of x equal to x square plus 1. Substitute the value, that is 1 plus 1 is equal to 2. Therefore, left limit is equal to right limit. Left limit is equal to right limit, therefore the function has a limit exist. Therefore, f of x has a limit exist at x equal to 1. F of x has a limit exist at x equal to 1.